you gonna do? Easy come, come the way you go. I'll never find what I'm looking for.
Hello and welcome to today's tutorial on comparing two conditions on SPSS. Today I will be taking an example from the Counselling Psychology workbook. So this will give those on the straight and criminal behaviour course extra practice in this example. Okay, so for your lecture and workshop this week, we have the following example. So, a researcher conducted research into the effects of engaging with computerised therapy package, Beating the Blues, on psychological well-being. The study employed a within subjects design, okay, so we need to pay attention to that, and used 22 participants. All participants completed a questionnaire to assess how happy they felt about their life both before and after taking part in the therapy session. Okay, so the key word here is both before and after. The questionnaire scored happiness on a scale from 0 to 20, where a score of 20 indicated very happy and a score of 0 indicated very unhappy. Their data were as follows. So we can see that the same participant took part before the therapy and then after, and indicated how happy they were. So therefore we have a within subjects design, and this will influence the type of test that we use. So as you can see, I have opened SPSS and clicked onto variable view in the bottom left hand corner, and I've entered the two variables that we have in the example. So we have before the intervention took place and then after the intervention took place. Now, because the scores of happiness were rated on a scale from 0 to 20, the data is ordinal in nature. Okay, so I've just told SPSS that the data is ordinal. Always make sure that your data is numeric in nature as well, as this will cause problems further on down the line. I then click back to data view, and you can see that I've copied the data into the data set. So for example, this is participant 1, and before the happiness intervention, she scored 10 on the happiness scale. After the intervention, she scored 13 on the happiness scale. Okay, so because we have a within subjects design and pre-tests of normality and distribution may show that the data is skewed, then we would need to perform a non-parametric test. So I'll just give you a second to enter the data into SPSS and think about what test we may use for a repeated measures non-parametric test. Okay, so hopefully you've come to the same conclusion as me, and that is that Wilcoxon sign test is appropriate in this instance. This is because the data is within subjects and may not be normally distributed. That you can calculate in your own time. So I would go to Analyse, down to Non-parametric tests, across to Legacy Dialogues, and then I would click on two related samples. Okay, so we have two related samples because we have a within subjects design. Okay, so if I just pop this box, you should receive this box here. So we've got the before variable. So if I just pop them back over, you can see what I've done. So it's asking for the first pair of variables. So I would click on before as variable 1 and click on after as variable 2. I would then click on the Wilcoxon test type, make sure that is ticked. I could click on options and ask for the descriptives. It will only give me the mean and standard deviation. For ordinal data, the median and interquartile range is most useful. However, the mean can give us an indication of the direction of the data in this example. and then I'd click OK. Okay, so as you can see, this is our descriptives table. Ideally, the median and interquartile range would be relevant for ordinal data. However, just to give you a taste of the data and the trends, we can see that the scores on the happiness scale before the intervention were around 8.45. And we can see that after the intervention, the mean score was around 10.01, if we round it up. Okay, so we can see a difference. We can see that scores of happiness appears to increase after the intervention has taken place. But is this difference significant? This is where we need to look at the Wilcox and Simon-Ranks test outputs, particularly this table here. So the first figure gives you the Z value. We will need this. And then the second one is the P value. This is going to tell us whether the findings are significant or not. So if the finding is less than 0.05, it is significant. So hopefully you'll agree with me that we have a significant effect here. Basically, this means that the differences we see here in the mean and the median, the mean between the before group and the after is significant. So perhaps the intervention did have an effect on happiness. Okay, so this is how we would report the findings. So we would state that the data was on an ordinal scale, therefore a Wilcox and Simon-Ranks test was appropriate to analyse the data. You would then state that the difference between the conditions were significant, and we would take the Z value from the SPSS output, the number of participants, and then present the Z value, which was minus 2.574. So if you go back to your output, you will see that in that bottom table, and then the P value. So it was significant, and it was quite highly significant. So we would say P equals 0.01. And then we would put it into context. So what does this actually mean? So it means that participants felt significantly happier after the computerised therapy than before the intervention. And then you could provide a table. Always make sure that you provide a clear title to your table, and that the title is placed in italics. Here you can see that I have presented the median and interquartile range. That is standard procedure. However, there is some flexibility, and you could present the mean and standard deviation instead. But again, we can see the same trends. We can see that the median was lower for the before condition than the after condition. There was a greater spread of data in the after condition compared to the before condition. Okay, so you may want to have a cup of tea or a little bit of a break before going on to the second one. But if you're still with me, good. Let's carry on and let's do the second example. Okay, so we have a slightly different scenario here. So a researcher is interested in studying satisfaction with counselling in individuals over the age of 80. He splits the participants into two groups. The first group, which has 20 participants, is condition 1, represents individuals in group nursing homes with more than 80 residents. And the second group also has 20 participants, condition 2, represents individuals who are supported in their own homes. He asks all participants to complete a questionnaire which measures their satisfaction with taking part in counselling sessions on a Likert scale from 1 to 5, where 1 indicates not satisfied and 5 indicates very satisfied. Okay, therefore the study has a between subjects design, so they were either in the nursing home or they were living at home. Okay, and you can see the data were as follows. So again, you might want to put some music on to make this bit a little bit more interesting, but if you open SPSS and attempt to put that data in, and I will meet you on the next slide. Okay, so this example is very different from the first example in how we would put it into SPSS. Okay, so a variable would be named condition. Okay, and we have two different conditions. So if you look back to the previous example, number 1 represented individuals in a nursing home, and number 2 represented individuals at home. So if we click onto values, we need to tell SPSS what we mean by this. So if we click on 1, and we're saying that everyone with 1 is in the nursing home, no spaces, and remember to click add, and then number 2 at home. So those represent all the people that were not in a nursing home and were being cared for at home. And add that, okay. Because we have two different groups, again, if you look at the symbols, they kind of give you an indication. 3 distinct circles there, so it would be nominal data. And then we have, what would the DB be? Okay, so what were the scores entailing? So we were actually measuring their satisfaction with their counselling sessions on a Likert scale of 1 to 5. So if we go back to SPSS, we could type in, we could label it satisfaction. Okay, again check that the data is numeric in nature. And because we have such a small range of scores, and they were asked to rate or rank, the data is ordinal. Okay. You're now then ready to input our data into SPSS. Okay, so you can see that the data looks very different from the first example when we had a within subjects design. So when we have a between subjects design, we have double the participants, don't we? Because we have the first 20 took part in condition 1, so those were the individuals from the nursing home, and the other 20 participants were individuals that were at home. That's why we have a total participant count of 40. Okay, so it's quite common to make the mistake and to add a in nursing home, at home column. However, when we have between subjects, we create labels. So all the ones here represent in the nursing home, and that goes up to 20, and those were the scores for the satisfaction and counselling. And then from 21 to 40 are the scores relating to whether they were in, at home. Okay? So I hope that makes sense. So when we have a between subjects design, the data looks very different, and this is because we have to code the 1s and the 2s separately. So if you remember, if we went back to values, you can see that all 1s represent those at nursing home, and all those that are 2 are individuals living at home. We then have their scores on satisfaction or counselling. Okay, so because we have ordinal level data, we have a non-parametric test. So we would go to Analyze, down to Non-parametric tests, across to Legacy Dialogues. But because we have 2 different groups here, they can't be in the same group. So we have number 1s and number 2s. We go to 2 independent samples. So I'm just going to show you what I've done. So it asks for the grouping variable. So this constitutes the condition. It will also ask you to define the groups. This is simple. So group 1 we labelled as 1 and group 2 we labelled as 2. Continue. And then the test variable, or the DB if you like, is satisfaction. We make sure that we've got the Mann-Whitney test ticked there. And for options, we could click on descriptives. Again, it won't give us the median and interquartile range, but will give us the mean and standard deviation and some idea of the range of the data and the trends in the data. We click continue and then click OK. Okay, so we can see here that okay, so this won't mean much because groups was just 1 and 2, so obviously it's going to come out as an average score. So if we look down here to the test statistics, we can see that the Mann-Whitney U statistic was 102.5, and the p-value, or the significance value, so always look for that significance value, is 0.007. So we then need to think to ourselves, is that greater or less than 0.05? Remember, if it's less than 0.05, it is significant. If it is greater than 0.05, it is non-significant. So I hope you agree with me that this is a significant result. Okay, so this is just a quick recap on how to calculate the median and interquartile range scores and a range of other statistics that may help you to understand the data. So I would go again to analyse, across down to descriptives, and across and down to explore. So you can see that in the factor list I've put condition, and in the dependent list I've put satisfaction. I've clicked on statistics and made sure that I've clicked descriptives, and then OK. And you should get an extensive table that looks something like this. So we can see that it's looking at satisfaction scores and comparing them between the nursing home and the individuals that were at home. And if we look down the list of different descriptive statistics, we can see the median right there. So the median for nursing at home is 2. So sorry, for in the nursing home is 2. And for individuals at home, the median was 4. Okay, so if you were wondering where those figures came from, again, the interquartile range, and then the interquartile range for the other condition. Okay, so this is how we would report the results in the results section of the practical report. The data were measured on an ordinal scale and therefore analysed using a Mann-Whitney U test. There was found to be a significant difference between the residential settings in the ratings of satisfaction. And here you can see the statistical notation. So U is the sign for the Mann-Whitney U test. N1 represents the number of participants in condition 1. N2 represents the number of participants in condition 2. 102.50 is the U value, so if we go back to SPSS, so we can see the Mann-Whitney U value right there, and then we would need to present the significance value. So P equals 0.007. 007, what about that? Huh? So with the participants receiving support in their own home rating their satisfaction with taking part in counselling sessions significantly higher than those in residential homes. Okay, so again, you'd provide a table slightly better than what I've done here. Again, you present a very clear title at the top in italics. Present the median score, so you can see for the nursing home it was lower than the own home, and the interquartile range remained similar in both conditions.